Hello friends, this is part 3 of solved paper Electromagnetic Theory, paper C-13 of 6th semester 2024 Dibrugarh University. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYZIT123. We have already solved up to question number 1. Question number 1 and 2. We have already solved these two questions. I have answered to all the questions in question number 1 and question number 2 in the last two videos. Okay, part 1 and part 2. So today I'm gonna answer to the question to the questions of question number 3, question number 3A, 3B. Okay. So now let's start. So here you see, state the Poynting theorem and write its mathematical form. Hence discuss the physical significance of the theorem. This question was asked in 2022 also. Okay, the same question number 3A, but in that question there was 7 marks because in that question you were asked to prove the theorem as well, but here you don't need to write the you don't need to prove this theorem in this question. You just need to write the statement and the mathematical expression. Okay. If you have solved the question paper of 2022, I have already made videos on that. Okay, so you're gonna find that 2022 videos, videos of 2022 paper in the same playlist. Okay, so this is the same question, but here you don't need to prove this. Here only 4 marks given. You need to write the statement. Okay, and the mathematical expression of the theorem and the physical significance. Okay, and the question which was asked in 2022, in that question you were asked to find prove the theorem as well, but here if to write this question, to write the answer to this question, ignore the proof part and just write the statement and the significance. Okay, so that's why I'm not writing the answer here again, because already it is solved in in that video where I have solved the 2022 paper. Okay, so now you see next 3A, or explain the Maxwell's modified Ampere's equation for the electromagnetic field. Okay, let me give you the answer to this question also. Actually I have explained this in the video where I have explained the Maxwell equations, all the 4 equations, but let me give you the answer again here. So here you see this Ampere's law modified by Maxwell. So here we have considered a circuit, you can see in this diagram. So this is a battery of EMF E, and here is the switch, and when this switch is on, then I current flows through it. Okay, I current flows through it, and here I have assumed a boundary of bounded by this L that bounds two surfaces, S1 and another is S2, which is hemispherical, and S1 is plane, and here C is the capacitor. C is the capacitance of the capacitor actually. So here you see, according to Ampere's law, if you apply the Ampere's law here, this S1 surface, then the relation between this magnetic field and the this current through it, because I current is passing through this, that will be given by this relation, this equation number 1. And now you see this surface S2, as there is no current through this surface, so when we apply the Ampere's law, then it gives this equation. Okay, here both the equations are wrong actually. Here you see, according to this equation number 2, there should not be any magnetic field this inside the between the two plates, but experimentally it was found there is magnetic field between this. We know that when current flows through a conductor, a magnetic field set up, but here you see between the conducting between the capacitor plates there is no current. But how does it how the magnetic effect comes here? How does the magnetic effect comes here? So let me tell you. So here you see, here Maxwell explains this. He said that change in electric field also produces magnetic field, and because you see, when this I current flows through this circuit, this capacitor start charging, charge will be accumulated on this, and now you see, when this capacitor, it must have a capacity, so when it will be fully charged, then no current will pass through the circuit when it will be fully charged. So current will continue to pass through to flow through this circuit when this change in electric field continues between these two plates, and due to the change in electric field, which is equivalent to the current, okay, that is responsible for the magnetic field, okay, the presence of magnetic effect here, okay, and that is equivalent to the displacement current here I have mentioned, okay. Let me go to the next page, take the screenshot, okay. So this displacement current, which is equal to epsilon naught d phi e by dt. So here phi e is the electric flux. This gives rate of change of electric flux. So that's why the Ampere's law, in addition to this mu naught I, there is another term, that is mu naught I dA, which is displacement current, and displacement current is equal to this, right? So that's why this is the modified Ampere's law. Let me show you again. This is the first page, take the screenshot, okay. This is the second page, take the screenshot, and this is the last page, okay. So hope you have understood this. Now let's move on to next question. So what is the next question here? Question number 3b, obtain the boundary conditions. I have already made a video on the boundary conditions, not only for the tangential components, I have already made it for the normal components as well. Both are in the same video, normal components and tangential components. The boundary conditions for tangential components, I have given the video link in the description box. I have written 3b, then I have given the link. And in that video, first you're gonna get the normal components, but to get the boundary conditions for the tangential components, you have to skip the video 16.24 minutes, okay. Then this topic will be started, okay. And if you need the both normal and tangential components, you can watch it from the start, okay, from the beginning, okay. So who knows, maybe this year you will be asked to write the boundary conditions for normal conditions as well, so it will be better if you watch the complete video. So link is in the description box, okay. I have made the video on this boundary conditions for both normal and tangential components, okay. So thank you for watching. See you in the next video. Next remaining questions will be solved in the remaining videos, okay. Thank you.